Okay, on number 1A, okay, what you want to do is your goal is to isolate your absolute value. That is your goal, okay? So you're going to isolate absolute value. Now, once you isolate your absolute value, you want to check and see what sign is on the other side. If you have an absolute value and you end up getting a negative on the other side, that would be no solution. So for example, if I had the absolute value of x plus 2 is equal to 5, that's acceptable. Okay. It could have been a positive 5 in here, or it could have been a negative 5 in there, because the absolute value of 5 and negative 5 both give you 5. If, however, we had a negative on the other side, once we got it isolated, that automatically would be no solution. Okay, so you have to isolate your absolute value. You need to see what's on the other side. You don't decide if it's positive or negative until it's isolated, because sometimes when you're doing the math, it can change. This one's going to be slightly more difficult because we are going to have an X on the outside. Okay, so first thing I'm going to do, my goal is to get this absolute value by itself. So the first thing I'm going to do is I am going to -1 here and -1 here. That's going to be the first thing that I'm going to do. Okay, when I do that, I'm going to get 3 times the absolute value of 2x minus 4 equals 3x plus 6. I still need to isolate my absolute value. I need to get this absolute value by itself. I do not want that 3 in front. You never distribute into your absolute value. Never, ever, ever, ever. So what I'm going to do is I am going to divide by 3. And over here, I'm going to divide that whole side by 3, but I'm going to divide each separately by 3, because that way I can get a more simplified answer. Okay. So when I do that, I'm going to end up with the absolute value of 2x minus 4 is equal to, and hopefully everyone's writing this down because this is going to go in our notes, x plus 2. Once you get it isolated, you're going to ask yourself, okay, what do I have on that other side? Is this a positive or a negative? When you have an x on the other side, you do not know, because it depends on what x is. If x is a positive number, or well, I should say this, if x is -2 or higher, that's okay. 0 is okay. But if it's anything smaller than a -2, that's going to be no solution, because I'm going to get a negative. So what you're going to do at the end, you're going to come here and into this, just that, you're going to check your answers. You're going to check your answers. And you want to make sure that you get a positive result. You don't care what your x is. Your x could be positive, your x can be negative. What do you get when you plug that in to x plus 2? So you're going to check your answers to see if this is positive or 0. 0 is acceptable. So really non-negative, okay? Now, this is review from integrated, well, both 2 and 1. You did absolute values in integrated 1. You may have seen ones like this. I showed my students ones like this. You may not, and just have done ones with numbers on the other side. We saw it a little bit more in integrated 2. So what we're going to do at this point, once it's isolated, okay, now I'm going to write 2 equations. So equation 1, And you don't need to write the one. I'm just want you to understand you're going to have two equations. One is going to be 2x minus 4 is equal to x plus 2. The second one is going to be 2x minus 4 is equal to the opposite of that. Okay, the opposite of that. So what's the opposite of x plus 2? A negative x minus 2. I make both sides opposite. I mean, everything on the other side opposite. Now we're going to solve. So when I solve this, I am going to minus x from both sides, and I'm going to get x minus 4 equals 2. I'm going to add 4 to both sides, and I get x is equal to 6. Now, I'm not going to circle that answer until I check it, okay? For number 2, the second equation, I'm going to add x to both sides, and I end up with a 3x minus 4 is equal to negative 2. I'm going to add 4 to both sides, and I get 3x is equal to, and when I add 4, I get a positive 2. Then when I divide by 3, I get x is equal to 2/3. Now, these two answers would be fine if I knew that what I circled in orange right here, this right here, is not negative. If I put 6 in here, will this be negative? No, because when I put 6 in here, I'll get an 8. That's acceptable. So I'm going to be substituting it in here. And when I do, I get a 6 plus 2, which is 8. So that's acceptable. That's going to be an answer. Then I'm going to be putting in a 2/3. So when I put a 2/3 in for that same x, I'm going to get 2/3 plus 2, which is really 2 2/3. That's also positive. So that's also going to be an answer. So what I'd like for you guys to do right now, try 1B. Okay, it's the same process. Try 1B. For 1B, after we try 1B, what we're going to do on this one is I want to, again, get my absolute value isolated, okay? So I want that x plus 7 in the absolute value isolated. My first step, I am going to add 5 here, add 5 here. I end up with 2 times the absolute value of x plus 7 is equal to 4x plus 2. Again, we never distribute into our absolute value. So I still want to get that absolute value by itself. I want to get rid of the 2. I am going to divide this side by 2, and I'm going to divide the whole side by 2, but I'm going to do each separately because 2 goes into both of them evenly. And so I'm going to get the absolute value of x plus 7 is equal to 2x plus 1. Once you have your absolute value isolated, okay, all by itself, whatever's on the other side, and on the other side, I have this 2x plus 1. That is where I'm going to check my answers right here. This is where I'm going to check to make sure not a negative result. At this point, I have no idea. A lot of us might look at this and go, oh, 2 is positive, 1 is positive. This has to be positive every time. Well, we're going to see that it isn't. So I'm going to work out the 2 equations. So one equation is going to be x plus 7 is equal to 2x plus 1. My second equation is going to be x plus 7, and I'm going to make that 2x plus 1 opposite, which means instead of it being a positive 2x, it's a negative 2x. Instead of it being a positive 1, it's a minus 1. And then I'm going to solve. So when I solve, I'm going to minus x from both sides on the first one, and I get x plus 1. I'm going to minus 1 on the first one, and I get x is equal to 6. And I'm going to check that answer here in a second. For the second equation, I'm going to add 2x to both sides, and I get 3x. I like to deal with my x's first, and I like to try to get my x's to be positive if I can. So I added 2x to both sides. Now I'm going to minus 7, and I'm going to get a negative 8. And I'm going to get a negative 8/3. These are the two things that I'm going to be substituting in. So for the first one, I am going to be taking this and putting it here. And I'm going to go 2 times 6 plus 1, which is going to be a positive 13. That's acceptable. That's going to be an answer. The second one, I am going to be substituting in a negative 8/3. So I'm going to go 2 times negative 8/3 plus 1. That's going to be a negative 16/3 plus, and I'm going to write 1 as 3/3. Okay, just that way we can kind of see 1's the same as 3/3. So I'm just going to write the 1 as a 3/3, and you see I get a negative 13/3. So this one here, not an answer. Okay, that one's not going to be an answer. Let me do it like this. That looks like I'm highlighting it. So this one here is not an answer. Okay, that one's not an answer. The only answer is going to be 6. Okay, that is our only answer. So on these problems, the one I did with us originally, both answers worked. The second one answer worked. It is possible to get no answers that work. So on this one, we have a system of equations. You guys are going to be doing 2A. 2A is not a system of equations, but I'm going to end up with the same type of equation once I set this up. When you have two equations that are y equal, you are going to do equal values from integrated 1. So what I'm going to do is I'm going to take the square root of x plus 2, since it equals y, and so does 2x minus 2. It also equals y. That means that both of these have to equal each other. So now at this point, after I've done this extra little step, I'm going to move it for a second. You're going to see that I get something that looks like A. Okay. Now, when we do a square root, just like when we do an absolute value, you want to isolate your square root. Okay, you want to isolate your square root. And again, just like an absolute value. Okay, I'm just going to jot this down and I'm going to erase it here in a second. If I have the square root of x is equal to 3, that's acceptable. If I have the square root of x is equal to negative 3, that is not acceptable. The square root graph looks like this. Okay. When they have no sign in front of the square root, they're asking for what they call the principal root. And again, I'm going to, well, I guess I'll leave this on here as an example. Okay. And the principal root is positive root. We really also could have a negative square root. If I had a negative square root, that would have been the bottom half. This is a negative. So when they have no sign in front, we are talking about the positive. So this one over here, where I have my positive square root is equal to negative, no solution, no solution. Okay. Just like with an absolute value. So when we personally take the square root of something, if I gave us a problem like this and I said, okay, x squared is equal to 9, you guys would square root, and you would give me the positive and the negative square root of 9. You would give me a positive -3. But when they draw the square root for you, you are being asked for the positive or the principal root. Okay. So we will have to check our answers. So where am I going to check my answer? I'm going to check my answer right here. Okay. There's really kind of two things I need to worry about with this problem. Okay. One thing I need to worry about is I cannot have this be a negative. This has to be a non-negative. It could be 0. That's acceptable. What about underneath the square root? Can I have this be negative? Can I have a negative under the square root and get something that's real? No. So we also need to make sure that this is also non-negative. Okay, so we have a little work to do when we're checking these types of problems. Okay, so if I am going to solve this, let me rewrite it. Okay, I'm going to rewrite it down here. So at this point, I am taking the square root of x plus 2 is equal to a 2x minus 2. My square root is isolated. I take a look to make sure that I don't have a negative on the other side. I am not sure what that is. I do not know. That's where I'm going to check. Okay, this is where I'm going to check. I need to check that. So how do I undo a square root? Well, the opposite of a square root is a square. So what I'm going to do is I'm going to square both sides. So I am going to square this side. I'm going to rewrite this so you see it. Okay, so I'm going to square this side and I'm going to square this side. So when I square this, that's easy. That's an x plus 2. It undoes. This, however, is a little bit more effort. So when I square that, I'm going to pause this for a second. I'm restarting it. This right here is a perfect square trinomial. Okay. If you need to work it out doing an area model, work it out doing an area model. Okay. I personally know the formula. And the formula is this. I'm going to do a minus because this is a minus. If I have a minus b squared, okay, where I have a quantity minus a quantity where I have something minus something and the whole thing squared. Square the first term. It's going to be a minus because there's a minus in between. Multiply those together and double it. And then square the last term. You should be getting a trinomial back. If you don't understand that, then do a box. But you want to start recognizing this so that if I have a 2x minus 2 and a 2x minus 2, you do not have to do all that math. So what I'm going to end up getting is a 4x squared. I'm going to multiply my 2x and -2 together. I get a -4x and I double that. So I get a -8x. I square my -2, I get a +4. If I do it in the box, in the area model, this would have been a 4x squared. This would have been a -4x, which is what I got when I multiplied these two together over here. I double that because I get another -4x. That's why it's doubled. You get it twice, every single time, every single time. And then a -2 times a -2 is really me squaring a -2, which is a 4. They are the same. Your goal is to start being able to do those ones fast because that's supposed to be a fast part of this little bit of a lengthy problem. Okay. Okay, so now that I have my x plus 2 is equal to 4x squared minus 8x plus 4, I have a quadratic. I need to get everything on one side, 0 on the other side. So I'm going to have 0 is equal to 4x squared. I'm going to minus the x from both sides and get a negative 9x. I'm going to minus the 2 from both sides and I'm going to get a plus 2. Now, we need to solve this either by factoring, quadratic formula, or completing the square. I usually don't like to use completing the square if I have a number in front of my x squared. Okay. You could do quadratic formula, but I think this actually is factorable. I'm going to move up to here. So I believe that if I was to do a box, 2 diamond, and I put my 4x squared here and my 2 here, those multiplied to a positive 8x squared, but they also have to add to that negative 9x. What multiplies to a positive 8 and adds to a negative 9? That's going to be a negative 8x and a negative x. So I'm going to get a negative 8x and a negative x. And now I'm going to try to find the outside. Okay. So for this, I'm going to focus on my 4x squared. That's what I'm going to focus on. So when I'm looking at that, it could be a 4x and an x. It could be a 2x and a 2x. Looking at that x there, I'm thinking not 2x and 2x. That won't be very helpful. I'm leaning towards the 4x giving me the 8x, the negative 8x, and the x giving me the 4x giving me the negative x. When I take my 4x and I multiply it with something to get a negative 8x, that's a negative 2. When I take my x times something to get me a negative x, that's a negative 1. So my factors are going to be 4x minus 1 and x minus 2. I am going to set both of these to 0. Okay. I'm really working out 4x minus 1 equals 0. I'm really working out x minus 2 equals 0. If you can do those in your head without writing equals 0, that's our goal. That is our goal. So here I would add 1 and divide by 4. So it's going to end up being a 1/4. The other one I would add 2. Those are my 2 answers. Now I need to check. Okay, and let me just rewrite this. Remember, check. And the original, well, where I was checking is this right here. And I really need to check 2 things. Number 1, will this be a positive when I put in a 1/4? So if I put a 1/4 in there, is that going to be positive? Will 2 times 1/4 minus 2 be a positive? No, this is going to be negative. So that is not going to be an answer. If I try this 2 and I go 2 times 2 minus 2, will that be a positive? Now, you also want to make sure that this is positive also underneath the radical. And so you also want to make sure that this is positive. Okay, and it is. It is. 2 plus 2 is a positive. So that means your answer is 2. That is your answer. So try 2A. Try 2A. So on this one, first step is to get your square root isolated. So we want to get this by itself. It is not, so we're going to add x to both sides. And when we do, we're going to have the square root of 2x plus 7 is equal to x plus 2. So we want to check here to make sure. I'm just going to get rid of that to make sure that this is a non-negative. It could be 0, it could be a positive. We also need to make sure that we don't get a negative here. Those are the two places I'm going to check. So I am going to square both sides. So let me just rewrite this. So I'm going to have a 2x plus 7 is equal to an x plus 2. I am going to square both sides. When I square a square root, it undoes and I get a 2x plus 7. When I square x plus 2 squared, you can either think of it as an x plus 2 times an x plus 2, or remember the formula for perfect square trinomials. This should be an x squared plus 4x plus 4. Okay, and if you do the box, you will get that. Now you're going to get everything on one side, 0 on the other side. So I am going to minus 2x from both sides. I am going to minus 7 from both sides because I want it to equal 0. I'm going to get 0 is equal to x squared plus 2x minus 3. I am going to factor that. So I'm going to get an plus 3, x minus 1. I solve this. I get x is equal to -3 and I get x is equal to 1. I need to check to see if they work. So I'm going to check this -3. And when I check this -3, -3 plus 2 is equal to a -1. So that one is not going to work. When I check my positive one in here, I get a 1 plus 2, which is a 3. That works. I also want to make sure that it makes the 2x plus 7 positive, which it will. So x equal 1 is a solution.